So we're going to continue on with solving these here. We did some of these yesterday. We're going to do a few more of these today. We're going to do at least one more of these here, and then we'll move on to the last part of 4.5. Now, this one here, we want to find all the real zeros for this here. 6x to the fourth minus 11x cubed minus 16x squared plus 2x plus 4. Now, one of the things we can start off with is finding the rational zeros, which is our plus or minus p over q. Would be a good place to start, because that'll give us an idea of what the possible rational zeros are going to be. Now, p is going to be the factors of the constant term, and q is the factors of the leading coefficient. So if we look at this one here, our constant term is 4. So we need to list the factors of 4. Well, we have 1 and 4, and 2 and 2. Now we're only going to list 2 once because we don't need to list it twice. So 1, 2, and 4 are all the factors of 4. Now we can list the factors of q, the leading coefficient, with it, which for this case is 6. So we'd have 1 and 6, and then 2 and 3. So the real zeros, or the possible rational zeros for this here, are going to come from p being 1, 2, and 4, bless you, and q being 1, 2, 3, or 6. And so what we can do now is we can start listing all the possible rational zeros. Well, really, we're going to start off with 1, plus or minus 1, plus or minus 2, and plus or minus 4, because when we divide anything by 1, we just get the number back, because 1 divided by 1 is 1, 2 divided by 1 is 2, and 4 divided by 1 is 4. So that really doesn't change anything for 1. Now let's look at 2. Well, 1 divided by 2 would be plus or minus 1/2. 2 divided by 2 is 1. We already have it. We don't have to write it again. And 4 divided by 2 is 2. We already had it. We're done with that. So let's move on to 3. So we're going to have plus or minus 1/3. We're always going to have the 1 over q because it won't simplify. So 1/3 we will have. Then we'll look at the next one, which would be 2 divided by 3, which would be plus or minus 2/3, because that's not listed. And last we have 4 divided by 3, which would be plus or minus 4/3. Any questions on any of this so far? So we've done it with, so we've got almost all of them. We just need to do 6. So we'll have plus or minus 1/6 for sure. And then we would do 2 divided by 6, which would be, well, not 3, it'd be 1/3, which we do have, and 4 divided by 6 would be 2/3. So these are all the possible rational zeros that we could have for this function here. Now we could start off again and use synthetic division and put 6, negative 11, negative 16, 2, and 4. Stay on the page. And just start off with positive 1 and see if that worked. Then go negative 1, positive 2, negative 2, positive 4, negative 4, and go all the way through and see if any of these work. But what was another method that we did before we started just doing this here? We did what? We graphed it. Yes. We graphed it in the graphing calculator. Because the graphing calculator will help us see what values of x will make this 0. Because anytime it crosses the x-axis, the value of y is going to be 0. So you can type it in, 6x to the fourth minus 11x to the third minus 16x squared plus 2x plus 4. And once we get this all typed in, once we hit y equals and typed it in, we're going to hit graph. We're going to hit graph. Once you get this all typed in, hit graph. So for positive, yes. Because we can say positive, it's between 0 and 1. And it looks like it'd be a little bit closer to 1. Closer to 1. We also have another one on the positive side that's close to 3, yes? Between 2 and 3, close to 3. Now, if we look over here on the negative side, that's real close to negative 1, that might be another set of zeros. Between negative 1 and 0, but it's close to negative 1. I'd say really close to negative 1, yes? Huh? Yep, about a dot, a pixel. So again, unfortunately, it doesn't look like in this here, the graph will not give us whole numbers because it didn't cross at any whole numbers. It didn't cross at positive or negative 1, positive or negative 2, or positive or negative 4. It didn't cross at any of those points. So none of these points work. So when I look at the rest of these here, actually we have one that's really close to negative 1. And looking at most of these here, 1/2 that would be between, that's not it. Negative 1/2 wouldn't work, negative 1/3 wouldn't work. Negative 2/3 might, but I don't think so. So looking between negative 1 and 0 might be a little hard to find. So let's stick with the positive ones. One that's between 0 and 1 and kind of closer to 1. 2/3. Let's try 2/3. Positive 2/3. So we're going to do our multiplication first. 2/3 times 6 would be our first one. And you could type this in a calculator. Well, 2 times 6 would be 12 over 3, which would be 4. So you have that typed in. Then what we would do, we'd add it to negative 11, yes? So I mean the calculator, then you can hit plus negative 11 and hit enter, which is negative 7. Then we can hit times 2/3, which would be negative 14/3. And then we could add it to negative 16, which would be and then we can multiply that by 2/3, and we would get negative 124 over 9. And if we multiply, if we add this again, and I'm going to stop this right here because this doesn't look like this is going to work out. Because these numbers are not getting any better. So 2/3 didn't work. You know what? Let's just try 1/2. Let's see. because it looks like it's going to be closer to 1, but let's just try 1/2. 1/2 times 6 is 3. Negative 11 plus 3 would be negative 8. Negative 1/2 times negative 8 would be negative 16 plus negative 4 would be 1/2 times negative 20 would be negative 2 plus negative 10 is so hey, that one did work out. So it did, I would agree, it did look like it was closer to 1, but it actually turned out it was right between them. So it gave us a clue as to see what it could be. So 2/3 was a good shot at kind of saying it was closer to 1. But if I look at any of the others, none of the others match up to being real close to 1. 4/3 is greater than 1. 1/6 is way less than 1. 2/3, 1/3, these don't work. I just tried another one. I just tried 1/2.
Yeah, I know, but like, if 1/2 or if 2/3 didn't work, how do you find a closer to 2? None of those are like.
I would move on. I would try a different one. So, because those here, or we can look back at this here, closer to 1. Because two and 2/3, maybe. 4/3. So let's look back at the graph and see what it has. Yes. Okay. I'll get you some more batteries here in a little bit. Yep. So that's what we have. Then we have these here. You know what? Let's try the 2/3 again. But I want to try the other side. I want to try negative 2/3. Because it's hard for us to really judge the distance on that line. So really what I'm trying is the one between negative 1 and 0. Now, negative 2/3 times 6, well, we did this one earlier. Almost. But this time it'll be negative 4. Well, negative 8 plus negative 4 is negative. So now we can do negative 2/3 times negative 12. Well, negative and negative would give us a positive 24 over, which would be 8. Well, negative 20 plus 8 is 12. Because it'll give us 8 again, 0. So, hey, we found them. So it just worked out that using those and plugging them in and trying them ended up helping us find it. So some of these here aren't as easy to find as others, because if we get whole number answers, it's a little bit easier to work with. Any questions on this here? We good with this here? Okay. Well, we could keep trying, or I could see that this here is a quadratic. 6x squared minus 12x minus 12 is equal to 0. Yeah, no, that's fine. Let's do that. Because yes, you are right. There's a common factor of 6 between all these, yes? So I could factor it out. which would leave me with x squared minus 2x minus 2 is equal to 0, yes? I'm not really worried about this 6, but now we can use the quadratic formula on this here. Because what that really did is the greatest common factor that would have simplified later on is already simplified. We don't have to do as much in the end. So our quadratic formula is negative b. Well, negative 2 is just plus or minus the square root of negative 2 squared minus 4 times a times c all over, well, 2 times 1, which would just be 2. Well, now we can simplify what's inside the radical. So negative 2 squared, which would be 4. Negative 4 times 1 is negative 4. Negative 4 times negative 2 would be plus 8. And 4 plus 8 is 12. Any questions on any of this here? Are we still good? Yeah. Yeah, negative 2. Now, if we simplify the radical, this here, the square root of 12 is 4 times 3, so we'd end up getting 2 square root of 3 over 2. So how many answers do I have here with 1 plus or minus the square root of 3? 2, because we have 1 plus the square root of 3 and 1 minus the square root of 3. So we also know x is equal to negative 2/3 and x is equal to 1/2. And we're done. Those are all the solutions for this here. Questions on this here? All right, if we're good with this here, let's move on to this one here. Let's do the factors of q first. So what are the factors of q, our leading coefficient? 1, right? Because the leading coefficient is 1, so the only factors of 1 are 1. Now the factors of p, our constant term is 24, so we would have 1 and 2 and 12, 3 and 8, 4 and 6. Any questions on how we found the factors of 24, the factors of the constant term, or the factors of the leading coefficient? Factors 1. Since it's only 1 for q, well, we really just have just the factors of p, plus or minus those factors. Yes? Okay. So what would we do next in solving for the real zeros? What would we need to do? Graph it. We would need to graph it. So I would go y equals, well, x to the third minus 5x squared minus 2x plus 24. Okay. And once we get this typed in, hit graph. It looks like it, but let's make sure. Let's do second graph. -2, 3, and 4. We're done. We're done. Huh? Well, that's going to be it for this one here, and we'll go into more detail in the next one, or in the next chapter of exactly why. But if I do the division, 1, -5, -2, +24, drop the 1. Well, 1 times -2 would be -2. -5 plus -2 would be -7. -2 times -7 would be 14. -2 plus 14 would be 12. -2 times 12 would be -24. We would get 0. Then we can do it with 3. 1 times 3 is 3. -7 plus 3 is -4. 3 times -4 would be -12, which gives us 0. So I'm left with x minus 4 equals 0. Add 4, add 4. And that's it, because we don't have any other solutions that'll come from it. Okay? And what we'll learn in the next chapter, the fundamental theorem of algebra, will tell us how many solutions are possible. The theorem itself will give us the number of solutions. So once we find that many, we know we're done. We can stop. Any other questions on this here? We're okay with this here? Yes? We're going to move on to the next one here. And this is the last thing we're going to do in 4.5. The irrational conjugate theorem. Let a polynomial function, let f be a polynomial function with rational coefficients, and let an a and b be real numbers such that a be rational numbers such that the square root of b is irrational. If a plus the square root of b is a 0 of the function, then a minus b is also. Really what this is saying is if I have this, x is equal to a plus the square root of b, if this is a solution, then x is equal to a minus the square root of b has to be a solution also. They go in pairs, just like our complex solutions. If a plus bi is a solution, a minus bi is a solution also. The same thing's true with our irrational numbers. If x is equal to a plus the square root of b is a solution, then x equals a minus the square root of b is also a solution. If we have one, we have to have the other. We good with this here? Okay. Write a polynomial function of least degree that has a rational coefficient and a leading coefficient of 1, and the zeros of 3 and 2 plus the square root of 5. So really what we're saying for this here is that x is equal to 3 and x is equal to 2 plus the square root of 5. We're pretty much doing the exact opposite of what we've been doing all week. Because all week we've been starting with a polynomial expression or function, yes, and finding out what solutions it has. Now we're going backwards. We're given the solutions. We want to find the polynomial function. Well, there's one more. Equals 2 minus the square root of 5. Is if I have a positive square root anywhere in there, I have to have its conjugate. We have to have both. Okay? Now, when we solve these normally, we started with the polynomial function when we did factoring. We would factor it into multiple sets of parentheses, yes? So I'm going to do a new page, and I just kind of want you all to watch this. So we had our polynomial function to the start. Then we factored it to, we had something, something, something times, yes? And then I set equal to 0, and set this thing here equal to 0, and then found out that this equaled something, and this equaled something else, yes? Because we solved it. We're going backwards. Because they gave us the last step. They told us that this is equal to this, and this is equal to this. Go back to this here. So what we want to do first is we want both of these, whatever our solutions are, all of these here to equal 0. We want them to equal 0 because we're going backwards. So this here, to get it equal to 0, I would subtract 3 from both sides, because 3 minus 3 will be 0, and I would have x minus 3. These two here is going to take more than one step, because I have two things. I have the square root of 5, and I have the 2. So I can subtract 2 first, because 2 minus 2 would be 0. So I'd have x minus 2 equals the square root of 5. Then what would we do? We would minus the square root of 5. This really is going to give us x minus 2 minus square root of 5 is equal to 0. Any questions on any of these here? Okay, we'll do it with this one also. So I'm going to minus 2 first. Kind of like what we did here, because we'll minus 2. But to give me x minus 2 equals, well, negative square root of 5. So since it's negative square root of 5 this time, I have to add square root of 5 to both sides. Any questions on any of this here? Any questions on any of this here so far? No? Hopefully you write small because you're about to run out of room. Because when we were solving, we had the polynomial function, we factored it to sets of parentheses that were equal to 0. If we have more than one thing equal to 0, one of them has to be 0. So we'd split them apart equal to 0, yes? So we're going backwards. Since I have more than one thing equal to 0, what am I going to do? I'm going to multiply them together. So what we're going to have is x minus 3 times x minus 2 minus the square root of 5 times x minus 2 plus the square root of 5 we're going to have to multiply these together. Now, when we multiply these together, always start out with the conjugates. Always start out with the conjugates. Because have any of the polynomial functions that we've come across or used had a square root in them? They've had square roots in solutions, yes, but not where we started with. That's why I'm suggesting we start here. Because we'll have x minus 3. Now over here, x times x would be x squared. X times negative 2 would be negative 2x. x times square root of 5 is going to be plus x square root 5. Negative 2 times x will be negative 2x. Negative 2 times negative 2 would be plus 4. And negative 2 times square root of 5 will be negative 2 square root of 5. Square root of 5 times x is negative x square root 5. Negative 2 times negative square root of 5 times negative 2 would be plus 2 square root of 5. Negative square root of 5 times the square root of 5 would be negative what? It'd be the square root of 5 squared, because it's the same thing, or the square root of 25. Because 5 times 5 would be, and the square root of 25 is 5. So it simplifies. Now this might seem, why did we do this first? Well, let's see here. So we have x squared. That's the only term with x squared, yes? So let's write it. We'll have negative 2x, and those are the only two x's without any radicals, yes? So that would be negative 2 and negative 2 would not give me negative 2. It would give me negative 4x. X squared of 5, negative x squared of 5. What would happen to those two? They cancel out. They're the same, yes? So this is gone. Okay. Negative 2 square root of 5 and 2 square root of 5. Those would cancel. Do I have any radicals left? No. That's why we do this first, because it will simplify every single radical out. And all we're left with is 4 minus 5, which would be minus 1. We're almost done. We have to multiply, bless you, we have to multiply one more time. Huh? Okay. Let's multiply through by x first. X times x squared would be x cubed. X times negative 4x would be negative 4x squared. And x times negative 1 would be negative x. And then we'd multiply through by the negative 3. Well, negative 3 times x squared is going to be negative 3x squared. Negative 3 times negative 4x would be plus 12x. And negative 3 times negative 1 would be plus 3. And if we combine like terms, x cubed is by itself. Negative 4x squared and negative 3x squared would give us negative 7x squared. Negative x plus 12x would be plus 11x plus 3. And that would be it. That's all we would need to do for this here. Any questions on this here? Any questions on anything we've done so far? Are you good with this here? Yeah. Yes. There'll be probably one. Let's look at this one here. Now they told us that the zeros for this is x is equal to 4 and x is equal to 1 minus the square root of 5. So we know x is also equal to what? 1 plus square root of 5. Now we need to set each one of these equal to 0. So we're going to get everything on one side of the equation. So the first one here, I'm going to subtract 4 from both sides, giving me x minus 4 is equal to 0. Here we're going to subtract 1 first, giving us x minus 1 is equal to negative square root of 5. And then we would add the square root of 5 to both sides, which would give us x minus 1 plus the square root of 5 is equal to 0. And then we'll do a similar thing with this last one here, because we would subtract 1, which would give us x minus 1 is equal to the square root of 5. And this time we wouldn't add the square root of 5 to both sides, we would subtract it, giving us x minus 1 minus the square root of 5 is equal to 0. Questions on this here? Okay. So now that we have all three of these here equal to 0, we're going to do what? We're going to multiply them together. We're going to multiply them together. So we would have x minus 4 times x minus 1 plus the square root of 5 times x minus 1 almost minus the square root of 5 equals 0. Any questions on how we got to this part here? We good with this here so far? Yes? Now we're going to multiply the second two here, so we'll do x times x, which would give us x squared. X times negative 1 would be negative x. X times negative square root of 5 would be negative x square root of 5. Then we do the next term, negative 1. Well, negative 1 times x would be negative x. Negative 1 times negative 1 would be plus 1. And negative 1 times negative square root of 5 would be plus the square root of 5. And lastly, we'll do the square root of 5. So square root of 5 times x would be plus x square root 5. Square root of 5 times negative 1 would be negative square root of 5. And the square root of 5 times negative square root of 5 would be negative 5. Because square root of 5 times the square root of 5 would be the square root of 5 squared, and the square and square root would cancel, yes? Are we comfortable with saying that? Yes? Now we can combine like terms, x minus 4. Well, x squared is the only term. We have negative x, so negative 2x. Now, negative x squared root of 5 and x squared root of 5, these cancel. Square root of 5 and negative square root of 5 would cancel. And that leaves me with 1 minus 5, which would be negative 4. Let me simplify this here. Questions on this here? Are we good with this here? Yes? Okay. Last but not least, we're going to multiply this last one here. So we're going to do x multiplied all the way through. X times x squared would be x cubed. X times negative 2x will be negative 2x squared. X times negative 4 will be negative 4x. We good with this here? Yes? Then we do negative 4 times x squared, yes? And sometimes when I'm doing this here, I'm not going to put it over here. I'll just put negative 4x squared. I'm just going to line the terms up. Because if I have a lot of these, I line them up so I know what matches. Negative 4 times negative 2x would be negative 8x. And negative 4 times negative 4 would be plus 16. Well, we would have x cubed, because that's the only term that's like it. Well, negative 2x squared plus negative 4x squared would be negative 4x plus negative 8x is negative. And really on the last one, we should have had it set equal to 0, but it's okay. And this is what we have here. Questions on this here? So this here, it's mainly just a lot of steps. We're doing a lot of steps, one after the other, yes? Do you want to see one more? Yes? If you're good with this here, that's fine. I will post up the assignment here in a little bit. But I'm going to go on and do this one here just so that you can see it. Yes? Huh? Yes. If you want to go on and work on the other assignments, that's fine. If you want to follow along with this here, that's fine. You can do either one. If the bell rings before I finish, and it probably will, I'm going to keep recording this here. So if you want to come back and rewatch this one, it will be here for you. Okay? So here it gave us multiple zeros. So x is equal to 0, x is equal to 5, and x is equal to negative 5 plus the square root of 8. Well, it also means I have negative 5 minus the square root of 8. Well, this one here has something interesting. It has x equal to 0, yes? Is that one already equal to 0? Okay, I don't have to do anything with that one. But here I have to subtract 5 from both sides, which would give me x minus 5 is equal to 0. Okay. Now this one here, I would add 5 to both sides. And when I add 5 to both sides, I'll get x plus 5 equals the square root of 8. And then I'm going to subtract the square root of 8 from both sides, and these would cancel, giving me x plus 5 minus the square root of 8 is equal to 0. Now you might be saying the square root of 8 does simplify, and it does, because it would simplify to 2 square root of 2. But I'm going to leave it as the square root of 8. Because as we've seen with all of these here, the square roots simplify out, so it doesn't matter in the end. Add 5 and get x plus 5 equals negative square root of 8. This time we would add the square root of 8 to both sides. You get x plus 5 plus the square root of 8 is equal to 0. Let's see. So this time when we multiply, we're going to be multiplying a few more things together, yes? Now I'm still going to start off with the square roots first, but I can actually do this here pretty easily. X times x is x squared, yes? X times negative 5 would be negative 5x. That one's done. So let's go on and do this one here. X times x would be x squared. And then x times 5 would be plus 5x, and x times square root of 8 would be plus x square root of 8. Then we would have 5 times x would be plus 5x, plus 25, because 5 times 5, and plus 5 square root of 8. So that would get us the middle one. And lastly, we'd have this one here, the negative 8, square root of 8. Would be the negative square root of 8. So when we multiply through this here, we would end up getting, I'm going to run out of room, negative x square root of 8, negative 5 square root of 8, and then minus 8, because our negative square root of 8 times square root of 8 would give us just 8, because it's the negative square root of 8 squared. At this point here, we can combine like terms. So we just have x squared, because there's no other like terms with x squared. Now we would have 5x and 5x as like terms, so those would add together to give us 10x. Now, if we look at x squared of 8, and we have negative x squared of 8, these two here would cancel, as well as negative 5 squared of 8 and 5 squared of 8. Those would cancel, leaving us with our 25 and negative 8. Well, those two would combine to give us positive 17. And then we're going to multiply through. Yeah, you can go on. It's fine. So if we multiply these two here, well, we get x squared times x squared, which would be x to the 4th. X squared times 10x would be plus 10x cubed. And 10x times 17 would be plus 17x squared. So we finish that one there. Now, negative 5x times x squared will be negative 5x cubed. And I just line it up like this here so that I can kind of combine like terms going straight down. Now, negative 5x times 10x will be negative 50x squared. And negative 5x times 17 is going to be negative 85x, I believe. 17 times 5, 5, carry the 3, 5, 6, 7, 8, yes. And it would be negative. Now at this point here, we can add these together to finish this out. X to the 4th is by itself, there's no other like terms. 10x to the 3rd plus negative 5x to the 3rd would be plus 5x to the 3rd. 17x squared plus negative 50x squared is going to be negative 33x squared, and we have minus 85x, and this here is equal to 0. And that's all we have to do for this here. So this here would be our lowest degree polynomial function for this here. And that's it. That's all we have to do for this problem here. And we are done with this section.